All right. I think we'll start right on time. So, hi everyone again. Today's speaker is Dr. Lydia Chilton. She's an assistant professor in the computer science department at Columbia University. Her research is in computational design, how computation and AI can help people with design innovation and creative problem solving, with applications that include creating graphics for journalism, developing technology for public libraries, improving risk communication during hurricanes, and helping scientists explain their work on Twitter. Today, she'll be talking to us about AI tools for design and innovation. So with that, I'll hand it over to you. Thanks so much for joining us.
Thank you so much. And I encourage, if you want to interrupt at any time, if we were here in person, I would want to meet some of you guys, like first, before, while we were eating some lunch or whatever, so I could better connect to my audience. But I do know some of you guys, so I'm just going to jump into it. AI tools, design, innovation, lots of buzzwords. That's the game of bingo I'm playing, but this does have some depth to it. So let's get going. Deep background, me. I teach and I study the design process. So traditionally, this is you brainstorm a broad set of ideas, you prototype multiple of those ideas, and you keep improving it with testing and improving, testing and improving. So you do this over and over and over again. I love this. I think this is deep. I think this is right. Obviously, you have to repeat it, but this is so important because people have misguided instincts about design, innovation, building stuff, making things. Every year in my class and in my own self, I see like people trying to short circuit the process of I'll just have an idea and I'll build that idea and I will release a product and I will be done. This is the linear way that we sort of think that it's going to happen. The problem with this is, what if something goes wrong? Because when you have to, and when things go wrong, you have to start all over. So like you build, and your AI doesn't work. You have to start over. Like, the amount of information doesn't actually, fit their context. We got to start over. Like, actually the mobile app doesn't update enough. And can you release? You're like, guess what? We needed better security. We needed better user accounts. Like, we needed this, that, and next thing. So if you see, you're gonna start over anyway, every time something goes wrong. And so why don't you just build that into the entire process? So the design process guides people to explore multiple ideas quickly and in parallel. So brainstorming a broad set of things to begin with, prototyping them rather than just building them out, and then testing and improving. And then this goes on pretty much forever, but at some point you got to release something, submit your paper, have your product, whatever, but you're always testing and improving over and over again. But that's a lot of work. And so how can we make this easier? I would rather go straight from an idea to a product and not have to brainstorm multiple things. Like, this is annoying. So I get why people don't always do this, even if they know that it's the right thing to do. So this talk has two parts. How can design make each step of this design process easier? And I have this graphic design problem that I use to apply it to. And then we're going to switch and talk about like, how can we use the design process to build useful AI applications? Okay, so two sides, like how to make the process better with design and how to design for AI. Okay, how can AI make design easier? So what's hard about each step? I'm first going to just talk about this application domain because it's kind of weird. So it's called visual metaphors. Here is a cover of The Economist about Brazil taking off. And you see an image of a symbol of Brazil kind of blended with a rocket, which is a metaphor for taking off. So this is from the news. This is an ad. And it's for trying to convey that Tabasco is hot. So it's like a fire extinguisher blended with the Tabasco bottle. This is a public service announcement about global warming, that the earth is melting. So these are all visual metaphors. They blend two symbols into one object to try to convey a message in this really graphically interesting way. And it's a creative challenge for a number of reasons. My biggest evidence is if you Google creative ads, this is the kind of thing that comes up. Right. And so you're seeing like McDonald's has Wi-Fi, Red Bull gives you energy, Absolute Vodka is fashionable, Nivea night cream, smoking kills, Barilla pasta, which is you happy, like these go on and on. So this is like proof by Google that there's something creative about these, more than if you just said literally the words McDonald's has Wi-Fi. It's eye-catching, it's symbolic. Okay, and that's what makes it hard. You can't just sit down and have one of these pop into your head. So you're gonna want to use the design process. So how can AI help design visual metaphors? So we're going to rely on this process. AI cannot do this whole thing for you. I know that that's what the news media would tell you about AI, that it's going to take your job and do your job and make everything faster. It's not. You got to find an isolated problem, and it can possibly help with some parts of that. So here, the parts of the process we think about is brainstorming. Here, that's coming up with what are the symbols of Starbucks? What are the symbols of summer? Prototyping. How might some of these things go together such that they fit well? And then once you have a prototype of two things that fit, how can you improve that to just make the blend a little bit more seamless in terms of its color and its quality and maybe its message as well. Okay. And so there's a general pipeline that we first built to do this, and we know without any AI. So you can brainstorm by yourself or with a group of friends, and you just write things. You can do that. And then you can go and find those images and label their parts. And then the computer can like help you combine some of those parts. The most important thing is it's coming up with multiple prototypes. You've got the sun and the Starbucks logo. You've got the water can and the cup. You've got the Frappuccino and the popsicle together. All of these are really lo-fi. They're only good enough for you to say like, basically, yeah, that's kind of working. Or basically like, no, I don't like that meaning. So I'm showing 3, but typically it'll come up with like 20. And a handful of those, like between 2 and 5 will be good. Anyway, so I hope that sort of makes concrete the design process and how these steps concretely get put together. And now I want to say at each step, we figured out what's hard about it and how we used AI to help. So with brainstorming, people can clearly come up with lots and lots of stuff, but it's actually hard. It just takes time. It took about 40 minutes to get a good brainstorm. And it's just by the time you're done with the brainstorm, you're just like exhausted. And so first was like, well, can't we just Google summer? Well, you get the word a bunch of times. You're not getting distinct and concrete objects. You get the word summer, you get a lot of beaches, you get stuff maybe you could pull out, like, oh, I could pull out those Adirondack chairs, or I could pull out the palm tree. Oh, but the palm tree is not entirely there. It's so hard to pull these things out that for summer, we want those symbols individually. It's better to just brainstorm them individually from scratch than try to pull them out of this image. So we use a combination of databases and AI and network algorithms to help people navigate a broad set of ideas quickly. I will just show you the system. So here we start with summer. So it's a pretty abstract concept. It's hard to visualize by itself. And we've run a clustering algorithm to get different definitions of that. And I will just show you this person browsing. So in like the beach sandals category, like, okay, sandals, that's a great vision of summer. Maybe a different kind of sandal, maybe not. Going on, beach, all right, that's a whole idea. Beach umbrella, that's totally a thing within beaches. Next category, beach ball. Yep, totally. That's another one. Moving on. Palm tree, great. Individual palm tree. Let's go to a totally different definition of summer, like swimming. All right, so goggles, that's part of it. Swimsuits, another nice concrete symbol. Let's go to a totally different meaning of summer. How about like barbecues? Great, so we have a whole barbecue. Individually within barbecue, we have like the tongs, maybe the hamburger itself. We may be getting a little further from summer, so you have to, as a human being who knows summer balance, is this still a good symbol? Maybe want some negative symbols like mowing the lawn. So you have to direct the search, but what's important about this is now you as the human just have to recognize what is good directions. So we've made it a recognition rather than a recall problem. Whereas what's hard about brainstorming is, let me just think. A whole bunch of summer stuff, just pulling things out of memory is hard. So we switched it using AI from a recall problem to a recognition problem. So that's great. Prototyping. So we built some tools to do this, but there's a trick to this. You sort of have to have an idea of how things might be combined. And we looked at a bunch of examples and sort of said, oh, there's a pattern to these. You have to blend two objects with the same shape. So that if the Earth is a sphere and the ice cream contains a sphere but has other parts, then you can blend them together. So it's not a recipe. It doesn't tell you exactly what to do, but it's an abstract design pattern. And you'll use these. This is a real thing that most creative people do. It's like, say, when you write an abstract to a paper, there's no like fill in the blank template, but you know, oh, first I say what the problem is, then what the solution is. And you could fit your data to that abstract pattern. Anyway, so with that pattern, well, first I'll just illustrate. So the Tabasco bottle, what shape is this? Well, it's basically a cylinder at some high level, which in 2D we can mask out with a rectangle. Great, so there it is. You're seeing a human being do this, which was the first version, but then this can be done by a machine. Now the fire extinguisher is also a cylinder, but it's only the main part of it that's the cylinder. It's got other bits sticking out, which help make it recognizable. Okay, so there's a first pass at getting a Tabasco and hot blend. Another example, this is a public service announcement for turn off your cell phone. So the light switch is also a rectangle. So here's where that rectangle is. It's all of it, which is important. And then the iPhone, also a rectangle. So at first we might think, oh, this is a really good match. But in fact, it's too good of a match, because if they're both rectangles, they'll totally occlude each other. It's bad. But luckily, the cell phone has this internal rectangle, which is just the screen. And if we mask out that part of it, then it leaves enough of the phone exposed that you can tell what it is. So here, the computer can like find multiple rectangles and you have to pick the. Now, adjusting these by hand, really hard, but computer can do that a lot easier than you can. So it's assisting you, making it faster. Making it faster means you can make more. That's the goal of design. All right, so now we've made prototypes. How in the world are we going to improve these? So this we had to develop a little bit of theory of what does it mean to iterate on something. So this is the prototype of the Starbucks and Sun image, and you can see it's got a green Starbucks logo in a yellow sun. So it sort of fits, but it's also kind of off. So what the tool does is take a dimension, a visual dimension like color, and say, how might we reblend the colors of these things? So it gives you, oh, first you gotta pick the silhouette. Sorry, I forgot about this. You pick the one with Starbucks in front. Great. Here it's giving you 3 or 4 different methods of blending color. These are all in Photoshop that if you look them up, you could figure out how to do it. But here it's just selected some presets and put them all in front of you. So it just lets you pick. You can see it and you can adjust the parameters, but you get what's going on. And so this person liked the one where you do a color removal rather than a combination or a multiplication or a transparency. You didn't even have to know the names of all these Photoshop functions. It's just previewing it for you. Another example of this. So this is a Lego in summer ad that's got the popsicle in there, and it's an okay blend on its own, but still we want to make it better. So we first think about silhouette. Do we want the Lego silhouette or the popsicle one? This person wanted the popsicle one. I thought that made it interesting. Now we can again do this color blending. It's finer grain details, but they sort of want some of that popsicle texture to come through on the Lego. And there's a number of ways you could have done this. This person liked that one, and then we're done. So there's a modest improvement, but it says something to have thought about both the silhouette and the color. One last example of this is here's a pretty bad blend of the orange and the snowman head. Here we pick the silhouette of the orange, and then you can do some color blending. But as you can see, oh, that color is too gross. Oh, that's too light. What you really want is the details of the snowman face back on top. So we have another little computer vision tool that allows you to grab the details off of something and then put it back onto the color blend. So there we have it. It's back. And now we've made a much better we've definitely improved this prototype from something like that doesn't even barely get the idea across to something with a lot of detail in it. You could continue to make these better, but the idea is to let people to get to this kind of a stage, like an MVP on their own through the process. So we tested this tool a bunch and found that it really helps people come up with more blends and better blends, like at 10 times the rate. But let me just give you an intuition of why. So one of our prompts in the study was bicycle and smart. It's the smart commute. So users unassisted would do things like this quite often, get stuck sort of improving their first idea, because this is the intuitive way to design. Come up with an idea. Oh, Einstein, bike, and then put it together. But if it doesn't work, people never start over. They just try harder. They move things around. They add more symbols, but they don't undo. That undoing is very hard. So they get stuck improving their first idea. Whereas if you come up with more symbols and have more options of ways to put them together, like we did in the VisiBlends case, you can just get better blends by having multiple of them. So that's great. Another way people get stuck. So here's one for New York City and night. So users unassisted almost all came up with the same thing, which was the moon and the skyline, which is not terrible. It fits. You could improve this, the meaning on this a lot. But the real problem with it is it's not so novel. This image exists, in many ways on the internet already. And everyone in the study came up with it. So if you want something a little bit more eye-catching, then you want different symbols in a different arrangement. And so one thing that people came up with in the system was blending the Metro card with the Big Dipper, right? And so this helped people brainstorm broader to get something that was more unique. Again, the theme is like more is better. If we could do them faster and have it be more fun, like less demanding in this NASA TLX kind of way, we get to more. And so we've used this tool, working with, so here's a startup that we work with called Lalo. They make drinks and they make them here in New York. And so they wanted a blend between Lalo, their brand, that's what their can looks like, and New York. So here it's a skyscraper that's being built. So we built this for them. But they wanted to post a ton of these on social media with different, like lemon and cool or time to lay low. Who even knows what these things mean? They just want these blends with multiple different messages. So that was a startup. We also worked at the beginning of COVID with a sort of student science journalism thing. And they want to do a whole science journalism page, like, I don't know, subheader of their site about investigating COVID. So we came up with a blend for them. And then for every article, we needed to come up with stuff. Here's like writing in COVID, and here's telehealth with the stethoscope plugged into their device. So just, these are the kind of things that people just kind of need to crank out, and they have to have something to do with the message. And just using stock photography is kind of lame. They definitely, articles get much better click-through if they have good images. Anyway. But whole point of this is data and AI can help brainstorm, prototype, and improve solutions. So it's not going to make these things from scratch, but it can help turn a recall problem into a recognition problem. It can help stop you from fiddling with all these little boxes and things, so getting like a prototype in place and then thinking about the dimensions on which you would improve it and giving you options automatically. All right. So great. So that's how AI can make design easier. But I also now want to switch and talk about how to use the design process to actually build AI applications. And the application I'm going to talk about today is summarizing meetings. So, right. The design process, generally brainstorm, prototype, test, and improve. But does that really work for building AI? And I had struggled with this for a long time, and I have a slightly different way that I advise doing this. So first of all, I want to introduce you in the bad way, as if it were a product. We would tell you like the idea, the product, the release, just to tell you what this summarization tool is. And then I'm going to talk about the real process of what we went through to make it. So the idea,
Every day we are surrounded by various forms of spoken dialogue. Interviews, debates, meetings, and conversations with friends and mentors. These are all rich sources of information. However, Accessing this information is difficult because these sources invariably contain the shared challenge of interpreting an auditorily rich stream of information. Now imagine receiving an email from a colleague about an exciting interview on YouTube. It's 23 minutes long, you're not sure if you want to commit to watching the whole thing, but you want to know if there's anything new or interesting in it. The goal of this system is to help people explore audio and find key takeaways quickly.
Great. So we want to use AI to help people find stuff in audio. All right. So how we build? So what do we build? Okay, I will take you through this. This has loaded into a podcast by Bill, where Bill Ackman is talking about money-related stuff, something financial, not my area of expertise. What it does is use automatic ASR, speech to text, and then does automatic summaries of that. Okay? And what you're seeing here on the side is sort of these bullet points of summaries. So the markets are a strange place for someone who isn't following the same path. That summarizes like the first bit of the audio. The more dominant large cap affects companies more than the average, and the S&P 500 is a cap weighted index. Seems like the market's moving more than usual because of computerized trading, right? So these are thoughts that are all in there, summarized out for you. So first, people tend to read the short summary to see if anything there is interesting to them. Then, if say they run across the 20th summarized bullet point, the healthcare system is getting better and people are going to be more careful. Then the system lets them see longer summaries, including reading the transcript and listening to the transcript to get more information on that. Right. So what is it? How is he saying it? So yeah, and so listening to the original transcript is kind of the worst. It's full of ums and ahs, but here you can see the long summary and read why he's thinking this. Healthcare system's getting better and better at treating the virus, so they're learning when to put people on a ventilator, when not to, and what drugs can have a positive effect. I think in a few months, it'll be a lot better because people are going to have more careful and the states will have to moderate their economic activity. Right. So this helped the person who was looking this, who didn't care that much about money, but did care about health, scan this and get right to a point where they're talking, how is a financial guy thinking about the healthcare system? So that's what it does. And we released this in a form of user study.
Out of all users,
and,
we find they spend 27% of the time they would have spent compared to listening to the full audio file.
Found that it takes 27% amount of time. And, you know, the typical thing you have in a paper, people liked it in many ways because it made something faster, because indexing into audio is really hard and boring, and transcripts of audio just have like ums, ahs, and these are interviews, and so you have to follow the thread, and I don't know, it's really annoying. So summarization is very helpful. Okay, so now I sort of pretended like the design process was like, ooh, problem, audio is difficult. Let's build something and let's show how much people like it. But that is not at all what the real design process was like. So I want to go through that. And in fact, we started with the tech, not with the problem. And this is super important. In design, they hammer, especially in human-centered design, they always talk about you want to start with a person and a problem and investigate needs. And whereas that's really, really true, the problem with AI is that the biggest risk is that the tech doesn't work yet. So how we always start is brainstorming multiple existing AI capabilities, and then brainstorm ways that we can combine them together to solve a problem. I can talk about why, from the way AI is structured, you have to combine them rather than just have it solve a whole, use them individually. And you can prototype these technical solutions, test and improve, refine. But as you, instead of just refining, you're sort of redefining the problem, because design is really all about mitigating risk. How am I going to prevent myself from having to start over? Well, I'm gonna spread my risk over all this. And the biggest risk is that what can the tech do? So that's what you have to figure out. What tech is out there? What does it do? And does it do it well enough for you to actually build an application that will help people? Now, it's going to get better, but at every point in the release, it has to do something. Okay, So brainstorming AI capabilities. What we do is we just read everything that comes out on archive and figure out what tech is doing. Speech recognition, sentiment analysis, summarization, translation, co-reference resolution, common sense reasoning, inference, text generation from a prompt. Right. So this is, we're not just thinking of this, it's more like data mining than it really is a brainstorm. But you want multiple options for what different AIs can do. And then you have to find working code, because people can say that speech recognition works, but does it really work? You want to so one great source of working AI is Allen NLP. It's just an API. You don't have to train it. You can just run it straight from the cloud there. Tons of things. And Hugging Face is a source of models that are pre-trained. So you can look, even for summarization, there are many, many, many models, whether it's trained on news, whether it's trained to summarize things from big chunks into small chunks, or small chunks into other. Anyway, so you want a lot of options, because some things work better for others and work different on data sets. So one thing about the AI world, what computer vision and natural language processing do is they work on core problems that are small but fundamental, like transcribing a sentence, or here are the entities in this sentence. And so each of these tasks individually are very foundational, but rarely useful in and of themselves. So that's why we think that you're going to have to compose these skills. I'm going to talk more about that, but I'll show you which ones we composed. So, and in fact, we do a whole brainstorm around what we can combine to solve. And I'm always thinking about knowledge management problems. I just have a baked in use case, because that's where information technology lives, is knowledge management, right? It's not going out there and helping the Knicks beat the Cavs, or it's not like that's like a robotics domain. But so we thought about a bunch of stuff. So speech recognition is great. If we put summarization on top of that, could we summarize meetings? Doing translation, can we do live translation? If we have language models and sentiment analysis, maybe we can track evolving trends. If we do text generation and knowledge bases, maybe we could do a better email autocomplete. If you do summarization and text generation, we can answer my emails for me. Anyway, lots and lots of ideas, and a lot of this isn't going to work, but then you get to try it out. The one that we went with so speech recognition was good, and summarization was kind of okay, but getting there. And so we went with this, and we didn't see a whole lot in this space. We did the literature review and found some stuff in the other spaces. But even though we got to brainstorming meetings, there are different types of meetings. There's research group meetings, there's doctor appointments, there's advisor-advisee meetings, there's TED Talk interviews, there's TV interviews, there's podcasts, there's having the whole cast of Silicon Valley talk about their experience, there's cooking classes. And we had to test speech recognition on each one of these domains. And one thing you find is that for some domains, it would be great to summarize doctor's appointments, but guess what? There's no data for that. So out of the box, no, we can't do it. Now, if you do have that data, then you can do that, but we didn't, so we couldn't. Advisor-advisee meetings, we recorded ourselves, we tried it, it didn't work very well. But either the things we were saying or how we were talking about them, or we were interrupting each other too much, didn't work very well. But the interviews from TED Talks, from Bloomberg TV, and from podcasts actually worked pretty well. That said, cooking classes, experts showing each other how to cook, did not work very well. There was a lot of speaker interruption, which doesn't do well. And these actors talking about their process, they're just making jokes and interrupting constantly, and that didn't work either. So it's not that speech recognition works or doesn't work. It will work to various degrees on different types of data, if that data exists. So anyway, so lots of brainstorming and prototyping around where, the context of whether these models will work. So there's this limitation that we can't summarize all meetings. It's got to be 2 speakers, and it's kind of have to have this interview structure. And so we pivoted to summarizing interviews. Here we are, we're changing the problem based on what the tech can do. Okay, And we also had to prototype multiple summarization models. This is really detailed. Let me not get into this too much. But basically, we had different models doing different things, and none of them can summarize the entire transcript at once, which was a problem. And so we have to divide it into chunks and recursively summarize. And you remember, so you saw like at first, there's the high level summary, but you can dig deeper to a mid-level, a longer summary, and get all the way to the automatic speech recognition. And so it would be great if we could summarize the whole sentence, the whole meeting, whole hour-long meeting into one sentence, but that's just not where it's at right now. So we can't build that application. So we can build something else that's weaker, but still useful. And that's the trick. Anyway, and then you have to test these summaries. So first, we just tested the smallish summaries, and people kept reading them, and they're like, "Yeah, I guess they're kind of interesting, but I wish I could know more about 5. My mom used to cook scrambled eggs in a cast iron skillet that was very smooth. I want to know more about that." Or 6, sorry. I used to follow my mom in the kitchen and duplicate her recipes from the Master Chef series. Oh, that's interesting. I want to know more about that. Which series, all this stuff. So I'm gonna get to the, yeah. So that's what prompted us to build this thing where this is not like a full summarization system, but helps you navigate interviews. So I know I said that it was summarizing meetings, but really now I'm backing off and saying it's helping you navigate interviews, right? And so just to answer this, the short summary says, I like to duplicate recipes. And the original transcript actually says that it was cooking shows like Julia Child and Graham on the Galloping Gourmet, and the PBS MasterChef series, which they was actually in the text. So it's definitely a weaker problem than we wanted to help people with, but summarizing is hard. And so doing it recursively, doing it with interviews is a good way to start. And hopefully as the technology gets better and we have more training data, we can improve this. But even for this application, it's pretty great, because I don't know about you, but I get these emails all the time where a colleague is like, "Hey, great 40-minute panel about diversity hiring." I'm like, oh, whereas I really want to watch this, I'm not sure I have 40 minutes to do it. And skipping around the video is not fun because you get YouTube ads and all this stuff. And so just getting a bullet pointed list that I can easily scan through and help find interesting things for myself, super useful. Anyway, so that was the first prototype. We had to do better we had to use another kind of NLP to figure out the semantic chunks of this. I don't want to get too far into it. So we had another data challenge in order to make the quality better, to fit into the model. Anyway, we used Allen NLP to do this. It was really helpful to know oh, there's a lot of other AI tricks out there to help patch your bad AI with some other AI to improve the quality. Anyway, great. And then we released the minimum viable product that we're talking about and that we ran the user studies on, and that people really genuinely found pretty useful for this task. Okay, but when designing for AI, what I really want to get across is, contrary to what you're told in the human-centered design process, here I really advise starting with the tech, given that you already have sort of a general area of problems that you're trying to help solve, whether it's knowledge management or healthcare or finance or whatever it is. There's lots of problems in the world, and you can find them. You're a smart person, you can go talk to people, you can do all that discovery, but you also are really constrained by what the tech can do. And so you want to have multiple types of tech, multiple models you can use on it, multiple things you can bind together. And when it's broken at some point, tech, you can come in and help boost quality. Because design's about mitigating risk, and for AI applications, the biggest risk right now, so the tech doesn't work yet. And I would say 5 years ago, it wasn't even close. I really struggled to make anything that was useful out of the papers were out there with some results that always looked good, but then when you ran the model, never worked that well. It was probably just overfitting to the data. That was my experience. And you can sort of see in conferences like Kai, it took a long time for us to see a lot of like, oh, deep learning application papers. And we're seeing them now, and we weren't really seeing them 5 years ago. And it's because there's been this shift in the quality of the AI and open, like things like Allen NLP, where you just have APIs that you can get this stuff and prototype more quickly and more easily. Okay, so just to summarize everything that I've been talking about, is that the design process is an invaluable tool for innovation. I really, really believe in brainstorming a broad set of ideas, prototyping multiple ideas, and improving the prototypes, and then repeating that to make it iteratively better and better and better. And this is so important because our natural instincts, even for someone who teaches this and practices it all the time, is to jump to the end, just have an idea and build it, and forget about the, oh yeah, but stuff goes wrong. And when things go wrong, you have to start over. And so the design process is really here to say, well, let's just take as a fundamental step that we're going to need to have a lot of ideas and do a lot of starting over, right? You're going to fail. You might as well fail fast, and you might as well explore things in parallel so that you don't have to go back to the beginning. That you have multiple ideas all going at once. Okay. But this is a lot of work, and we want to make it easier. So I have one application where data and AI can help people brainstorm, prototype, and improve solutions. We're working on others, particularly science journalism and the journalism process in general, like investigative journalism. Those are more writing and knowledge-based than image-based. The natural language AI is getting there. But in general, it's the brainstorming, the prototyping, and the those are isolated tasks that AI can actually help people with. It cannot do the whole job, but it can certainly assist. And we talked about the design process guiding you to multiple solutions, but does that really work for AI applications? And my answer is that not really. You do want to brainstorm, but we want to brainstorm around the tech capabilities and make sure that you have a lot of options there. Test things early to make sure the AI actually does what it says it does, and then work to narrow down and redefine the problem, given that you're in a space where there's lots of problems. Like we all are inundated with email and data, and we do sense making all the time, and AI is great for reading in a bunch of data and helping you make sense of it, whether it's with summaries, whether it's by picking out exemplars, whether it's by better search, anything. But you got to make sure that tech is working and on the domain that you want it to. So that is the past 7 years of my life. I would love to talk about anything and everything that you do, particularly as it relates to design. And if you use AI, that's great. If you're thinking of using it, that's another, I can talk about that too. And I know these applications are probably pretty far out of domain, given that you're in the medical context. So if you want to sort of brainstorm in your space, happy to talk about that too. I will just stop sharing so I can see all of your faces. And thank you.
Okay. Great. Thanks, Dr. Chilton. Can you guys hear me? Sorry. Yeah. Hello, hello.
Oh, I see some thumbs up.
We can hear you, Hal.
Yeah, we can hear you.
Yeah. Great. Thank you. Very great talk. Yeah, I think normally we are like facing a problem, and we try to like brainstorm what are the available technologies that can help solve partial of the problem. But here, like I heard a very interesting, the other way around, like exploring what are the capability of the tech available and see what kind of problem we can solve now. That's very interesting. Does anyone have questions? I already see. Yeah.
I think Pooja has a question.
Yeah. Just go ahead and ask. Thank you.
Thank you so much for a great talk. It was definitely really interesting to see and think about applications to the medical context. One of the questions I had is I was really curious looking at the VisiBlends tool. I was thinking about when you showed how novices were able to use that tool and come up with blends that they wouldn't have necessarily had the expertise to think about. We've done some past work in sort of the health domain around like how novices and experts differently conceive information and can relate different information together. I was really curious if you had the chance to test that system with experts and where they differed, or if it supported different parts of that design process for novices versus experts, and how different tools can support different people based on different levels of expertise that they may have.
Yes, we actually found two experts in making visual blends, and they had done it before. It was a crazy thing to find, but if you look around enough in life, I promise you, after this talk, you're like, oh, that's a visual blend. So you could find one and then try to track down the person. And there's lots of like professional graphic designers at Columbia, so lots of that. The thing with experts is they're a hard group to support, because whereas novices, like, they don't know anything. So anything that you give them is going to help. Novices, if they have their own path, you have to be really augmenting something they already do. Otherwise, they have to learn a new path that you're doing this on. But what the experts really, really liked in this path is they like the brainstorming. They're like, yeah, that's what I would do. It's just doing it faster. They didn't see they weren't quite as wowed by the faster as much as novices were, because I actually don't know why. Although, like, doing something fast is all anyway. But what the experts really liked was the ways of improving the tool, because improving the designs. They spend an awful lot of time in Photoshop working at the pixel level, like, oh, this pixel, that pixel. Sort of, if you write code, like really like, oh, debugging, like this little line, oh, I had two equal signs and not one, like all this stuff that I really feel like no human being should have to do. And just saying like, oh, these are all the things that I use in Photoshop, but it's applying them in this pipeline in a way that I can just pick and fiddle with the right things. And so for things that they do all the time, having like a streamlined workflow with the options to just recognize rather than have to recall or like re-manipulate that stuff was really valuable for them. And they were the ones, for novices, even novices would only want to do that once. They're like, I got my thing, I'm going to make it a better color yellow, and that's it. But experts wanted to do that and look at all the different ways that you could blend the things together. So I think, yeah, different stages. And the thing that's most painful for like the experts was the pixel twiddling. And so that's the part that they resonated with, whereas they brainstorm all the time. For novices, is even the brainstorming is hard. So that was really nice to have a tool, just think of 50 goddamn things that represent summer. Like, just do it. You know they're in your head, but having the computer just spit them out was easier for them. But if you're a designer, you've thought about that many, many times before. So anyway, yeah. So experts and novices tend to gravitate to different types of things, but it's based on their experience of what they find hard and this personally.
Yeah, and it's really interesting to see how you were able to combine both of those needs within that tool and within that process of like both those different users could find something valuable for where they were at. Yeah.
Sweet.
I think we'll do Matt,
please.
Matt, Jan, and then Kayla.
Hi, thank you very much for that interesting lecture. One thing I've noticed is a lot of your applications go towards some of the highest level human cognitive processes there are, like evoking an emotion with a picture, semantic analysis, email composition. And so given the state of where the technology is for now, it seems like some combination of both human input and automation are necessary. And my question for you is, in your workflow, have you found that there are certain processes that can be driven almost fully by automation, or is user input necessary at all stages? And then the other question I had for you, because I think about the application I kind of use design for is phenotyping and observational databases. And certainly when we run into phenotyping rare diseases, we don't have a lot of data to work with sometimes. And so I'm wondering if you found in your applications that you need a very large data set to get to these high level cognitive functions. for automation, or are there ways to work with smaller data to evoke emotions?
Okay, lots of interesting questions. Let me see if I can say some things that are relevant without trying to tackle anything. I'm a big believer of human in the loop for anything that actually matters, because the hardest part about a problem is actually writing down what the problem is in enough context to fully encapsulate it, which can almost never be done. And so you're almost always going to forget something. This is why computers and AI traditionally lived in the world of games like chess. The whole chessboard, that's it. There's nothing else. There's nothing about the room you're in or whatever. And so as soon as you bring some context in, that like, oh, well, what country are we going to put these visual blends in? Because guess what? Language and those sorts of, and context matter a ton. You need someone who's lived in the world, who can either recognize that this is a problem or patch in some of that contextual knowledge themselves, solve the problem. You need that human in the loop. And so you're right that the need for that contextual knowledge is much higher in higher level cognitive things like emotion and meaning and conveying stuff. That said, let's just, and even summarization has a lot of cognitive stuff. Now, even the automatic speech recognition, which should just be a pretty low level thing, like I need to hear the phonemes, translate them into words. That's pretty good. But pretty good is 99.9%, which sounds like a high number. It is a high number, but it's definitely not 100%. And there are like weird things that go wrong. And the problem is, what are you going to do with that? If you're just going to like caption a TV show, people have a tolerance for error and that. I was watching something the other day and they like the letter W just never showed up. So I have to figure out, but you can figure it out because you can interpret it. But there are some things that can be pretty unforgivable. And so it really, it's like in the medical domain, I imagine that like a lot of mistakes are pretty costly. So you really got to think about that pretty hard.
I can say I've been an end user of speech recognition in radiology, and when it drops a no when you're trying to say no cancer and puts out cancer, that's problematic.
That is a big one. In one of our, so in English, people use contractions a lot for the no, like didn't, and sometimes those get really clipped off and it changes the meaning. It's really bad. Something you didn't ask is, how could we use more AI to fix that? In fact, that's our next step, is that we have, it's okay, stuff that does like looking for inconsistent statements. And so if you notice this person is saying like, this person is feeling really ill, bad things like, oh, and they don't have cancer. It's like, maybe there's a logical consistency there. And so that's another level of AI that we could use to test summaries or transcripts or whatever for possible misinterpretations. So the more barriers and the more red flag catching you can, the better. There's a lot of other different ways of solving that. However, you asked another question is there any way to do AI without having a ton of data? That's how I interpreted your question. And almost, we're getting much closer. This has nothing to do with my work, just because I follow the literature. The big advance in AI is let's have huge models that are trained not on a specific task, but just on internet scale data. So yeah, maybe they'll have, so like we just crawl the entire internet of language, and then guess what? We get pretty good language models that can predict the next word just because they have a bunch of training. And then you just need to fine tune that a little bit more on a small set of data for that to be useful. And those transformer-based technologies are getting better. And this is an active area of NLP. And combining text and images is also helping, because images by themselves don't have any encoded knowledge, but knowledge and language by itself doesn't have any grounding in reality. And so being able to capture both of those together is going to be super helpful. Rather than just providing like, yes, cancer, no cancer, you could even say like, I think this one doesn't have cancer because, and you could maybe start to connect those and use like whole databases of every kind of like cell image or MRI or whatever it is, and just have a background knowledge of this is what MRIs are, what they look like, just create a model of that, and then learn on top of it. I'm optimistic about that. It's not there yet, but I would place a bet on it. So
Great, thank
hopefully
you.
something to look forward to.
Thanks so much for the talk. Really, really interesting. And I don't have a design background, and it flips my understanding of design on its head, kind of like going with the capabilities of AI first. And what little I know about design is from my friends in anthropology, and they always lead with do the qualitative research, do ethnographic field work, ask people what they're currently doing, and then maybe figure out what the needs are and build the technology. And so I'm curious if you know anybody using, say, the tools that you've built for summarizing interviews for the design process, because it seems like once you know the technology, then you're looking at that Venn diagram of like what people actually need. You do a bunch of user interviews and then summarize them and explore them to find that intersection.
So okay, I'm gonna say two things. The direct question is like, yes, we are trying to do this for investigative journalists who get a lot of their, like they're looking for kind of like leads, tips, ideas. But if you're pouring through a bunch of like YouTube videos or like whatever you have, you need some tools that are going to cluster, they're going to create the knowledge graphs by themselves, maybe with a little bit of help, like that's fine. So yes, that's exactly where that's going. Check back with me in a year to see if we were able to do anything about it. I also wanted to touch on your first point about human-centered design and starting with the problem versus starting with the solution. I really think to be controversial, I said, well, people say you should start with people, but I say you should start with the machine. In reality, it's exactly in the middle. I would think of good design as you have a whole bunch of people, like a marketplace, lots and lots of people, and lots of technologies, and then you kind of just want to find good combinations. It really is a market. And that's a kind of, I've not seen this way of describing design in HCI or computer science as much. It is in the mechanical engineering literature, which a lot of design comes out of, but I think that's a pretty fair way of categorizing it, because if you are an anthropologist and you've done interviews with people, very often you find a lot of problems that tech can't help you with. So for example, we work with public libraries, and public libraries try to help people not just with books, but a lot of things. It turns out the basic problem people had was not enough money. And that wasn't something that we felt computationally we could do something about. But guess what? Like, people have to fill out forms in order to figure out whether they qualify for benefits. And that was hard. So we made kind of a TurboTax for SNAP applications. So that, it was a part of that problem. We had to really expand, and we couldn't solve the root problem of people are poor, but, we could do other things. And so exploring a lot of options on both sides is really where it's at. Maybe I should just say that in the talk and cut all the drama. But I think this is why, as researchers, doing it longer helps, because you build up that catalog of problems and a catalog of solutions. And so naturally, you encounter like a new technology comes out and you're like, oh, actually, I know a problem from 20 years ago that we couldn't solve, but now we can. So that's the fair way to think about it.
Yeah, it's super cool.
Hey, echoing all the thank yous. This has been a really interesting talk. One thing that I was kind of thinking about, and I'm thinking of the slide you had with like the visual representation of how many people will stick to the early idea and just try to force it around versus actually explore multiple ideas. Particularly in differential diagnoses and things like that, we've discussed in actually with Lena's class on decision support, how experts will kind of early on find the diagnosis they want to go to and stick with that. Novices will tend to explore more. With visual metaphors, I can kind of really easily imagine how it is to try to direct people's attentions to more places than just that earlier image when you kind of have, okay, here's that map of the diagram of all possible brainstorm. How do you think about it though, if like, let's say there isn't that kind of visual representation of thinking about how you actually direct attention around, maybe considering like how expert somebody is, how likely they are to have already kind of stumbled on a right answer or a viable thought or product, however kind of that may be. With in a visual case, it seems pretty clear, but I was kind of wondering how that might, how attention grabbing might work and kind of trying to diversify attention when you don't have that really clear depiction of it.
I think I understand what you're saying. Let me say some things and see if they answer it. So one thing experts do is if you've seen all the cases before, you can kind of brute force the solution and you may not need to. So like Google now, it's like the first hit is right, like pretty much every time. And and that's what a lot of deep learning does, a lot of big data. It's just you have all the answers already. You just need to find it in that stack. In that case, now it's actually harder and harder to find these problems like visual blends with the internet can't, like where Google search can't just solve it for you. We actually need to recombine things, well, which is good in some ways. So experts have this, can sometimes just jump to conclusions and it can be quite right because they're just looking it up in the book in their head and going for it. That said, there's a lot of research on when experts are right to do this and when experts are wrong to do this. So for example, in like forecasting, guessing what the future is another word for forecasting, experts are pretty terrible. And because they just leap to conclusions and who knows what they're basing this on. But if you ask people to sit down and like catalog, oh, here is what I see, here is the evidence, here are multiple things that could be, and let me write a pro-con list, they get a lot better at it. So just by slowing down that process and doing, I don't even know if I call that design, but sort of, you observe, you consider multiple things, right? So it's a mini process. People get better. I think this was actually done for medical people. I think that's where the original studies come from. So that's a case where I would say the design, you have to look, when are people jumping to conclusions where there's like, but how did you, if it feels like magic, you got to figure out, or is it magic because it's a code book and they've just seen it all before? Or are they just jumping to conclusions like someone forecasting would? Forecasting is the perfect example because you cannot look it up in a book because it hasn't happened yet. And people are pretty terrible at it in general. So I don't know that I answered your question, but I know that example comes from the visual space and it's very hard to project that back onto another space. But another problem we do this for is with journalists. Say I have a story, how do I come up with a punchy way of pitching it to people? It's kind of like coming up with a headline. And there are some heuristics, like if it's really timely, you lead with that. Or if there's something that's really dangerous, you lead with that. And so we can find ways of saying, here's, you're writing the story about, the Knicks losing last night. You could connect it to this important thing. You could talk about how, we may be losing Madison Square Garden because, so you can help people just say, here are different ways of thinking about that in the intellectual space. And then just by presenting them with multiple options, it's hard to get people to just think harder, but if the computer can give you options and some of those are pretty decent, you can sometimes get people to stop and say, oh, I'll consider your suggestion. I might throw it away. But that would be my guess of a way to help people do design who don't really want to do design and are busy and just need to get to the right answer, but may be willing to stop. Because but you need some sort of tool, I would say, rather than just tell them, oh, just think harder. Just do the next time you think about jumping to a conclusion, don't. That's just too hard. You need some sort of intervention to make that, to assist them in doing that.
Thanks.
Do we have time for one more question, comment? I kind of feel
yeah.
I need to weigh in here a bit with all our students in attendance on this whole debate between human-centered design versus computer-centered design. As a HCI student in the College of Computing at Georgia Tech, a hammer in search of a nail was always sort of a way to describe computer science that is trying to apply the same solution or searching for a problem. So Lydia, thank you. This was a great talk. I wonder if you would agree maybe with another perspective on this, is that starting with human problems may always be a good idea, but in some cases, when technology is moldable and easy to work with, like writing interactive system software, we can actually build a more direct solutions that are more specifically fit problems. But with machine learning and AI, where the systems are much more complex, and typically there is not, a variety that you can build a custom solution, a custom model, a custom set of computational modeling technique for every problem. Maybe it becomes more of a marketplace that you're talking about, where it's less about, we may not be equipped yet to build a completely new computational modeling approach for every problem. And what we're doing is we're finding a match between human problems and the modeling techniques that we currently have.
Yeah, and in fact, I would characterize that as exactly right, particularly for emerging technologies like AI that we don't actually know what they can do yet. For apps, we all know what a phone app can do. And so now, since that's sort of locked in, it's important to, talk to people to figure out like which part of their life we can help with now that we know what the technology is. But when the technology is unclear and is going to get better, you really kind of have to refine the technology at the same time. I will also make a pitch for something that most technologies that come out, we don't know what they're ultimately going to be for. And so there's some sense in just probing the system and trying to figure out stuff it does well. Not all technology really just solves a problem, or even if it does, it's like, so Bitcoin was meant to be a banking system, but now it's like NFTs and supply chains, and it solves a really broad class of problems. But no one was out there thinking like, I have a supply chain problem, how might we fix this? It was adapted from a different set of needs. So technology is kind of wild like that too, which is why I like the marketplace thought. And Bitcoin was also sort of in this emerging technology bucket. So I think that's a good, asterisk to put on things. When you think about a technology, is it emerging or is it kind of there? Where is it in its life cycle? So you can think about how to design based on the risk factors.
Okay.
Awesome.
Thank you.
Thank you. Yeah, thank you.
Thank you guys so much.
Yeah. I think given the time limit, we have to stop here. But a quick question for Dr. Chilton: is the two models or like tools are public available, or do you mind share the GitHub or repository or something? If that's
yes, there are multiple GitHub repositories. The hierarchical summarization one just got published. I think it's there. I can follow up with those links.
Yeah. Please follow up with Shreya, Harry, or me. Any of us. Then
great.
That would be really appreciated. Yeah. Thanks for the great talk. Yeah.
Thank you so much. All right, take care.
I'll see you guys next time.
Just one plug, folks, for a talk on Thursday as part of our DEI series. Charisse Madlock Brown will be presenting at noon. Nancy will send out a reminder. Thank you so much.
Okay, thank you, Harry.